Okay, so now we're on to this little manufacturing example. And this is kind of related, and we don't do a huge amount of this in this class, but this idea of Six Sigma. And the idea here is that about, 99% of any distribution was within three standard deviations of the mean, i.e., is within this range of Six Sigma. And if we have some sort of a manufacturing process, then this Six Sigma should be within, whatever our specific quality specifications are. So let's just kind of take this data. It's just really a set of manufacturing measurements. It could be like the length length of a screw or something like that, or the weight of some maybe drink product, or how much has been filled in the drink product. So it's just some general manufacturing measurement. So we're going to first calculate the mean for this. And now we're going to calculate the standard deviation. And we're just going to use, we assume it's a, and I said in this instance, it doesn't matter too much, but we're going to just assume that we're going to do it as a sample. So again, we're just going to take the same. Now what we're going to do is we're going to calculate the range of our Six Sigma, e.g. 3 standard deviations in either direction. So this is going to be mean minus 3 times standard deviation. So minus 3 times this value. And this is going to be the mean plus the 3 times the standard deviations. And then we're just going to have the total amount of the variation across the process is just going to be the difference between these values. .7. Now, actually, let's just kind of format these consistently. But I could actually just do 6 times the standard deviation, and I would actually get exactly the same answer. So this is basically just 6 standard deviations, our Six Sigma. And we've got, this is our specification for our manufacturing process. Now here, we've said, okay, this is our specification. So ideally, we'd want this 99%. I think it's, if you look in the book on page 140, we're looking about 99.7%. So we ideally want our 99% of measurements to fit in this range. So this range should actually be bigger than our Six Sigma. So ideally, this range should be bigger than the 0.7. And what this kind of process capability index, I'll actually just call it that so we're not confused. What this does is this is just what what our quality standards are divided by our Six Sigma. Now, ideally, this should be greater than 1. Our Six Sigma should lie within our specification range. So say, for example, we had a standard deviation of, say, 0.05, that our Six Sigma would be 0.3, and our Six Sigma would lie within our specification range. So this is really just, this is relating to process manufacturing and this idea that, if we have a specification range, 99.7% of all our measurements should be within that range. So the idea is this should be greater than 1. And ideally, if we go back to our original, our 0.12, if we had a specification, if we had slightly more lax specifications, then you can see we just about, again, get over 1. So going back to our initial example, here we are. Let's just, yeah. This is not a very capable process in that we have our, this is our quality standards. We want it from 4.8 to 5.2, but 99.7% of the observations via, again, if you look at the book, Chevnychev's inequality, they're actually have this range between 4.6 and 5.34. And so the spread is just too wide relative to our actual specifications. And yeah, to get a little bit of insight, I've just kind of quickly, I didn't show this, but I've just quickly created the bins for a histogram. So let's just show this data set in a histogram. So let's just go data analysis, histogram. And you can see I set it up to get A3 to H27, this data set. Let's just redo the bins. Got the bins here, we're going to put it up here. And you can see here kind of this distribution. And again, like most manufacturing processes, you've got most near the mean, then you've got a few little kind of outliers. And here we have a few little outliers kind of skewed to the right. So again, to fit within the to fit the Six Sigma within 4.8 to 5.2, we'd need to kind of squash this process and remove some of these outliers to bring our capability process above 1.